Okay, so hello and welcome. In this particular video, I now want to start a new section, and the section is called Patterns and Sequences, or Sequences and Series, and that's what we're going to be looking at. So let's start that, right? So we are looking at sequences, and series. And so what we really want to do is we want to start looking at the definitions of each of these things. Okay, so let's start with the idea of a sequence. What is a sequence? Well, I'm going to tell you a sequence is simply, that pen is a bit thick, and so let's get a thin pen going. A sequence is simply an ordered set of numbers, or an ordered set of objects, really. It's an ordered collection of numbers, or an ordered collection of objects. Right, and so that's the first part of this definition. The second thing we want to look at is, what is the definition of a series? So this thing I gave you over here is a sequence, right? And now let's look at what is a series. Well, a series is simply the sum of that objects. It is the sum of the objects, or the collection. Or let's use the word elements. Okay? And that really gives us a series. Now, what we are going to look at is we're going to actually look at a certain set of or a certain subset of different kinds of sequences, right? All I'm trying to say is we're going to look at specific types, but remember that a sequence is just an ordered collection of numbers, and a series is the sum of that ordered collection of numbers or objects. Okay, so unlike functions where we deal with sets, right? Sets can have elements. Those elements are considered members of a set. And so a sequence is similar to a set, but it differs slightly. It also has elements, it also has members, but the key difference that we look at is going to be the following. Order matters. Order matters. Order is very important for this, right? Order matters. And then let's talk about this. Let's use an example. There's a few examples. 1, 4, 7, 9, 32. That over there is considered a sequence, right? It is a sequence of numbers where there's 1, 4, 7, 9, and 32. Okay, I'm going to use other numbers. -2, 0, -2, 0, 2, 4, and so on. And then you can also get numbers like 2, -2, 32, 17, and all of these are considered sequences. All of these are considered sequences. The only difference is, what makes it a sequence is that it is an ordered set of numbers. That's the idea. 1 must be before 4, 4 must be before 7. In this case, 2 must be before -2, as well as -2 must be before 32, and 32 must be before 17. I just mean when we talk about these numbers, their order in which we present them matters. Okay? So I've defined the sequence to be a sequence of this order. Okay, now for the purposes of high school, we start looking at not sequences per se. We look at sequences, but really a subsection of sequences, a part of sequences. We don't look at all, we don't look at complex bounds and all of these things. We only look at patterns, and we look at their series, right? And so what we are interested in is 3 different common patterns. For example, 3, 5, 7, 9, right? This is one type of pattern. The other type of pattern is going to be something of the form 2, 4, 8, 16, right? Similarly speaking, we can also get a pattern that looks like this. So we can also get a pattern that looks like this. 4, 7, 12, 19, and if we want to, we can add another one, 28. Now, all of these are considered sequences, right? And remember, if we go one definition back, a sequence is simply an ordered set of numbers, or an ordered collection of numbers, right? And a series is just the sum of the elements of that collection. While the most important thing here is that order matters. It doesn't need to have a pattern. It doesn't mean we're always adding a constant difference or we're always multiplying by the same number. It just needs to be a string of numbers in which we present them in a certain order. And so if I change this order, it will no longer be the same sequence. But if I change the order, it will be the same set, right? And so a set is just a collection of objects. And a sequence is an ordered collection of objects. Now, we are dealing with sequences that have a specific pattern, okay? But a sequence doesn't have to have a specific pattern. We are just dealing with ones that have specific patterns. Okay, so let's look at each of these individually. All of these are examples of sequences, and in fact, these are all three different kinds of sequences. These are different sequences, different kinds of sequences, or different sequence types, right? And I'm going to put that over there. And so let's look at the first one, the very first kind that you see over there. 3, 5, 7, 9. 3, 5, 7, 9, right? Let's see how we look at 3, 5, 7, 9. In this case, I'm adding 2. Wow, that's very good. And from 5 to 7, I also add 2. And from 7 to 9, I'm also adding 2. Okay, what's happening in the second case? 2, 4, 8, 16. Now, you may investigate that sequence and tell me that, well, that sequence, 2, 4, 8, 16, is actually powers of 2. But you can also tell me what I'm doing between 2 and 4 is I'm multiplying by 2. And over there I'm also multiplying by 2. And over here I'm also multiplying by 2. And so this sequence over here is actually 2 to the power of 2, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4. And this type of sequence that is raised to a certain power, when it's raised to an index, we call this a geometric sequence, or an exponential sequence, right? Geometric sequence. I'm going to give you the name for the sequence that you see above when you add the same constant term each time. This is called a linear sequence or an arithmetic sequence. So the first term is arithmetic. It is also called a linear sequence. Right, and so there you have two types of sequences already. The third sequence that we looked at, was a sequence with the following numbers: 4, 7, 12, 19, and 28. So you're going to say, well, Imad, when you look at this, when I'm going from 4 to 7, I'm actually adding 3. And from 7 to 12, I'm actually adding 5. And from 12 to 19, I'm actually adding 7. And from 19 to 28, I'm actually adding 9. Okay, so as you can see, the first pattern, this first level over here, this is called the first differences, or the sequence of first differences, right? If I go to this over here, this is called first differences, and in this case there is a common difference. It's a common first difference. It's the same thing that we add each time, and we only do it in the first level, right? Over here, you can see that when we're moving from the one to the other, the first differences are not common. They are not constant. And so we need to look at another level. Between 3 and 5, I'm adding 2. And between 5 and 7, I'm adding 2. And between 7 and 9, I'm adding 2. And so this here is a second difference. But most importantly, it is a constant second difference. We're looking at constant second differences, right? And so this type of sequence, this sequence type is called a quadratic sequence. Okay, it is called a quadratic sequence. This type of sequence is called an arithmetic sequence, where we multiply by the same number each time. And that is going to be called, this thing over here is called the constant ratio. Right? Ratio. This thing over here, constant first difference. The constant first difference. And finally, with the quadratic sequence, we look at a constant second difference. And so those are the types of sequences we're going to be looking at, how to find their general term, how to develop a pattern for them, and how to determine any term of that particular sequence. Okay. Right. And so just a quick recap of what we've seen in this video is that we looked at three different types of sequences. We looked at the arithmetic sequence, and that's a sequence in which you add the same thing each time. For example, 3, 5, 7, 9. That's an arithmetic sequence. And the defining property is that it has a constant first difference. In other words, I'm adding the same thing each time. Okay. Then we also looked at a geometric sequence. And I'm going to, oh, that's meant to be one word. Why is there such a big gap there? Okay, geometric sequence. The geometric sequence that we use as an example here will be, let's say, 3, 6, 18, 54. And in this case, there's a constant ratio. Right? There is a constant ratio. Okay, and then finally we looked at a quadratic sequence, and the quadratic sequence that we used as an example. Quadratic sequence in our example is the following. I had 4, 7, 12, 19. And in this case, we had to look at the further patterns that say, well, okay, between there I'm adding 3, and there I'm adding 5, and there I am adding 7, right? And then between each of those I'm adding 2. And that there, the defining property, is a constant second difference. Okay, and so there you have it. That's the three types of sequences we looked at. A sequence is simply an ordered set of number, and we are looking at three specific types of sequences that also form patterns.